Hello and welcome to two-dimensional interactions, or law of conservation of momentum within two directions. The key thing here is we're just using the law of conservation of momentum, except the momentum is conserved within the x direction as well as within the y direction. So if we've got something moving at an angle, we can use the law of conservation, mv plus mv is equal to mv plus mv in the x direction, the horizontal, and we can do the same in the y direction. The thing is, afterwards, typically, what we're needing to do is then combine them afterwards to get a final full answer as we're breaking apart that conservation within the two directions. So, taking a look at our first example, we've got a 4 kilogram object traveling with a velocity of 2.8 meters per second south. So we're going to draw that 4.0 kilograms, and it's traveling 2.8 meters per second south. It's colliding with an object that's 6 kilograms, and it is traveling with a velocity of 3.0 meters per second west. These things are going to combine to make a 10 kilogram object. It's going to be going somewhere towards the southwest. Now, we can take a look at how momentum is conserved, first of all, within the x direction within this collision. Okay, so mv plus mv is equal to mv, and that will be the combined mass. Now, taking a look at the x direction only, we're just taking a look at this horizontal momentum, and it'll get us the horizontal components. So, we've got the 6 kilogram mass that is going 3 meters per second west, plus the 4 kilogram mass, which is not moving in any direction in the x direction. It's only moving in the y direction, is equal to that combined 10v. So as a result, you get negative 18 from this side is equal to 10v, or negative 1.8 is equal meters per second is equal to v. Now, that's just getting this horizontal component of the velocity afterwards. In order to find the other part, we're going to need to do the same thing using the y direction. mv plus mv is equal to the combined mv. The 6 has no velocity moving in the y direction. It is all caused, in this particular case, by the 4 kilogram object. And so we take that 4 times 2.8 gets you negative 11.8 meters per is equal to 10v, or negative 1.18 meters per second is equal to v. And that is south. And again, that is just getting this horizontal vertical component of that. We're going to need to now combine these two, right? We've got a velocity component of 1.8 west and another one going 1.18 meters per second south. And so the resultant will come this way, and that's what we're looking for, is this resultant. Finding the magnitude using the Pythagorean theorem. Okay. C squared is equal to a squared plus b squared, and so what you find is that c is equal to 2.12 meters per second as your magnitude. But we also need the direction, that's the angle, and the way that this angle's been drawn, we're looking for an answer that will get us south of west. Okay, tan theta is equal to opposite over adjacent, and when you solve for that angle, you're going to get 32 degrees south of west. Now, of course, that could also mean 58 degrees west of south would be an acceptable answer, or 212 degrees on the RCS scale. Taking a look at our next example, we've got a 4 kilogram object traveling east, but we're not given what this velocity is. It's going to collide with a stationary 6.0 kilogram object, so it's got a velocity of 0. And afterwards, this 4.0 kilogram object is going to shoot up at an angle of 32 degrees at a velocity of 2.8 meters per second. The 6 kilogram object is traveling now down with an angle of 41 degrees at 1.5 meters per second. So coming along east, and it deflects up and causing the 6 kilogram to move down. Now notice each of these in the end have both an X and a Y component. Looks something like that. And we're told that this is moving east, which means that really the Y components should cancel out. And so first thing we're going to do is we'll verify that here. So if we take a look at the Y component, we've got mv plus m. Well, actually, scratch that. Let's just take a look at those Y components. This Y component here is going to have a momentum mv of 4 kilograms multiplied by the velocity at this angle, sine 32. So when we take a look at that, what we get is, which gets you 5.93 kilogram meters per second going north. South, the momentum going south, again, is that mass, that's 6 times the velocity of 1.5 sine 41, and that gets you 5.90 kilogram meters per second. And initially that looks like it's an issue because they are different. However, when we take a look here, really all our numbers are to 2 significant digits, which means this is actually 5.9 and 5.9, and they are the same to 2 significant digits, which is important. That 0.03 kilogram meters per second of momentum, that could be accounted for within the possible measurement errors, both within the original as well as with our calculations. Okay. Taking a look at what's happening in the east, or the X direction, you've got mv plus mv is equal to mv plus mv. Okay, 4 times the velocity plus 6 times 0. Here, because this is what we're looking for, this original velocity, right here, right here. This had a velocity of 0, so 0 here. This deals with the X component of both the 4 and the 6 afterwards. So a mass of 4 multiplied by 2.8 cos 32, and adding to that 6 multiplied by 1.5 cos 41. Running through the calculations, the entire right side gets you 16.29, and so the velocity afterwards, dividing both sides by 4, winds up with an answer of 4.0 meters per second going east, and that is your answer. Okay, this third question is one for you to try. We've got that 115 kilogram a 115 gram arrow traveling 20 meters per second east, and embeds itself into a tennis ball moving north. And we want to find the direction, so we're just really looking for the direction here. At the end, we're not looking for the combined velocity. Pause the video, give this a try, and let's see how you do. Okay, so here is what we've got going on. We've already taken a look at the 115 going 20, 57 going 42 north, combined 172 going in some direction, and it's the direction that we're looking for. Solving for the velocity in the x direction. Now, we also could have simply used the total momentum in the x direction and used 22,300 here, gram meters per second, I should say. And here, instead of the 13.9, we could have used 2,393 gram meters per second. But we've used velocity here in the example. If you use momentum, that is fine. Finding the angle to be 46 degrees north of east. If you were looking for the magnitude, again, you would be looking for the c squared, and the magnitude of that velocity would have been 19.3 meters per second. That is not part of the question, that's why it's in orange there, but something to consider. Okay, we've got one more question in the examples. And an ornament, which is breaking apart into 3. Let's pick green. So we had an ornament here. It breaks off into 3 pits, and we just want to know the magnitude of the momentum. So we're going to stick with momentum here. Taking a look at what's happening, we've got an A component, B component, and a C component, but we're really just worried about the momentum, the conservation of momentum in this case. And so if we take a look at X, a little shortcut here is we're just going to use momentum of A plus the momentum of B is equal, plus the momentum of C is equal to 0. Because it started all at rest, no momentum, and it's going off there. We're taking a look at just the x direction, so this momentum is 2.52. Plus B, we're taking a look at the x direction of B, which is 1.91 cos 60. And we're looking for that momentum of C. This is all equaling 0. Okay, so you got 2.52 negative 0.955 plus PC is equal to 0. And what you find here is that the value here is negative 1.365 is equal to PC. That is the momentum of C in the x direction, 1.365. It is negative because it is going in that westerly direction. We're going to be doing the same thing in the y direction, right? Momentum of A plus the momentum of B plus the momentum of C is equal to 0. Now the momentum of A in the y direction is 0, which essentially means that B, the up, and the C down momentums should be equal and opposite. Okay, but running through this, we've got 1.91 sine 60 plus PC is equal to 0. And so taking 1.91 sine 60, that gets you positive 1.65 plus PC is equal to 0, or negative 1.65 is equal to PC. Right, and so that's this component, 1.65 going south. We want to find the magnitude, so it's c squared is equal to a squared plus b squared. And going through the Pythagorean theorem, you will find that the answer is 2.28 meters per second, or C. If you do have any questions, let me know. Hope this helps. Thanks for watching.